Welcome to the Welding Technology course. The course code for Welding Technology is PR8592 and it is a professional elective subject for the regulation 2017. So here in this video session, we'll be studying about Unit 5, where we have the title as Design of Weld Joints, Weldability and Testing of Weldments. So here in the syllabus, we'll be studying about various weld joint designs, welding defects, causes and remedies, weldability of aluminum, copper and stainless steels, and destructive and non-destructive testing of weldments. So here we'll be studying about the introduction to non-destructive testing methods. And here you have the different types of non-destructive testings. So here you have this visual examination, liquid penetrant testing, magnetic particle testing, eddy current testing, radiography testing, and ultrasonic testing. And these are all the non-destructive testing methods that you will be studying in the remaining 4 units. So the first one is the visual inspection, and the second one is the liquid penetrant method or the dye penetrant testing. And the third one is the magnetic particle testing, and fourth is the thermography testing, fifth is the eddy current testing, sixth one is the acoustic emission testing, and seventh one is the ultrasonic inspection, and eighth one is the radiography methods. So this visual inspection will be studying in the first unit, and the liquid penetrant method, magnetic particle testing will be studying in the second unit. Thermography and eddy current testing will be studying in the third unit, and acoustic emission and ultrasonic inspection will be studying in the fourth unit. The fifth unit will be studying about the radiography methods. So these are all the common applications of non-destructive testing: to ensure product integrity and reliability, to control manufacturing process, to lower the production costs, to maintain the quality level uniformly. And non-destructive testing can be performed during manufacturing and after manufacturing, and even on parts that are already in service. So coming to the applications of non-destructive testing, first is for power plant inspection. See here, you can see from the figure. So this eddy current testing is being used for testing of heat exchanger tubes. And the next one is the wire rope inspection. Here the cable wires are being tested by using the magnetic particle testing method. And here in this storage tank inspection is being carried out by the ultrasound testing method. And here you have this aircraft inspection, which has been tested. This thin outer body of the aircraft is being tested by the eddy current testing method. And here jet engine inspection, fluorescent penetrant is being used. That is the liquid penetrant testing, non-destructive testing method is used here to inspect the jet engine. And rail line inspection, that is the railway tracks, is being tested by using the magnetic particle testing method. And the bridge cables are being tested by using acoustic emission method. And the pipeline, here the pressure vessels, pipeline, and as well as the pressure vessel inspection is being carried out by using radiography testing method. So coming to the characteristics of non-destructive testing, it's applied directly to the product. The test is being carried out directly to the product, and the tested parts are not damaged. Various tests can be performed on the same product repeatedly. No specimen preparation is required, and this test can be performed on parts that are in service. The time consumption is very low, and the labor cost is also low. And this is the reliability. So the properties, the materials applicable, this liquid penetrant testing you can perform the test on all sorts of materials, whereas in the magnetic particle testing, only magnetic component can be tested. Eddy current testing, you can test only the current conducting material. Radiography and ultrasonic testing, you can test all types of materials. And the detection capability, liquid penitent testing, only the surface defects can be detected. In magnetic particle testing, you can detect the surface as well as subsurface defects. Similarly for eddy current also. And radiography and ultrasonic testing, you can test volumetric inspection. And the depth sizing for liquid penitent and magnetic particle testing, you can find out the depth of the crack which is present inside the test specimen. Whereas in eddy current, radiography and ultrasonic testing, you can find out the internal cracks, the depth at which the crack has been located. And orientation evaluation for liquid penitent and magnetic particle testing is not applicable, but in eddy current, the radiography and ultrasonic testing, orientation evaluation is applicable. So the following are the major factors that is affect the reliability. So the size of the defect, the type of non-destructive testing methods used, inspection environment, quality of equipment, and capability of the operator. And these are all the uses of non-destructive testing methods: flaw detection and evaluation, leak detection, determination of the location of the defects, dimensional measurements, structures and microstructure characterization, and estimation of mechanical and physical properties, stress, strain, and dynamic response measurements, material sorting, and chemical composition determination. And coming to the advantages of non-destructive testing, the equipments are easily to handle. Defects can be detected without damaging the components. The methods are quick and accurate, and the components can be sorted out on the basics of electrical, magnetic, or chemical properties. Test results and other informations can be recorded on the paper, films, cassettes, floppies, DVDs, CDs, etc. And the difficulties of non-destructive testing is skilled operators will be not available. Radiation hazards is there, and the power source requirement is there, and high cost of the equipment is the difficulties of non-destructive testing methods. And the surface must be clean and smooth. Demagnetization of components in magnetic particle testing is needed. And these are all the future progress in non-destructive testing. So there are two general trends with the non-destructive testing community that are influencing the development and both center around the operator. On the one hand, instrumentation is being developed to reduce the operator's involvement as much as possible by means of automations and computerizing results. On the other side, there are significant efforts to quantify the human element through training and qualification. So second in importance is increasing demand from users for more precision and reliability and more speed. And here the users become more dependent on non-destructive testing results to extend the support on component life and the low factor of safety. Finally, the need for specialized technicians as well as application specialists will grow to cope up with the opportunities being presented. And there is a new factor coming into non-destructive testing which seems likely to bring the major modifications to most of the non-destructive testing methods. That is by using computer techniques, small computers, and apart from this, it's rather trivial uses to simplify calculations. It is now possible to collect, store, and process vast quantities of data at very high speed. So these are all the future progress in the non-destructive testing. And with this, we come to an end to this non-destructive testing methods. So thank you and have a great day.